There is one common battle that every project management context and situation needs to face, and it's the fight between quality and speed. Most of people think that you need to choose between quality or speed, and that if you want to do things right, you need to go slower and vice versa, which is a general correct idea, but I still strongly suggest that we can do differently when it comes to software development. We have other opportunities and we need to strive to achieve technical excellence. And that's why. Hi, this is Dan, and we are in the new episode of the Weekly Pomodoro on Learn Agile Practices podcast. This is another English episode. I'm switching between English and Italian in this format because I want to move to English completely on one side, but on the other side, I still want to produce content on my native language. So this is working for me for now. And today, back in English, we talk about a very important topic in software, which is the historical fight between quality and speed. Is it actually true, that we need to sacrifice quality to go faster and vice versa? I'm not sure. Before starting, always remember to follow us. So if you're on YouTube, subscribe to the channel, leave a like, and leave a comment if you want. Share the episode with everyone you think could be interested, and do the same if you are on the podcast. Follow the podcast in every platform, whatever platform you use. And also remember that in the description you can find all the link to Learn Agile Practices, because I create a lot of content, not only podcast. There is a blog with long form content every month. There is a weekly newsletter, Agile Bits, which is a micro-learning newsletter that talks about Agile practices that enable technical excellence and business success, and a lot more. A lot of new things are coming, more focused on TDD lately. A new email course about TDD is coming soon, and also I'm running some webinars, 1 hour webinars on TDD that can help you learn the practice. And you can always contact me if you want to be supported in some other way. I'm happy to hear how can I help you. Now let's go with the jingle for the intro, and then we start. Okay, so quality versus speed. This is an historical fight in software development and in project management, and it looks like an impossible battle to solve. In general, it makes perfectly sense that we think that more quality needs us to go a bit slower. It's true in a lot of work, a lot of type of works. But there's another thing that is true in a lot of kind of works, every work actually, that if you are better at what you do, you will be faster and give the same quality in less time. So I think that we talk too little about this. I think that software development, since the outcome of software development is not a physical product, but it's an ephemeral product that runs as a software, we have, as always, different opportunities, more opportunities than other kind of work. So it's easier for us to achieve a certain level of technical excellence in what we do without sacrificing quality. And I strongly believe in that. And I also was able to witness this in previous companies, also when I was tech leading and I was trying to bring technical excellence in the team, and it worked. So that's what we discussed today. The common belief, as I said, is we need to go fast. We always need to go fast, right? When we are a startup, we need to go fast because we need to find the product market fit, probably. We need to find new customers. A new customer requested some features to then purchase the product, so we need to build the feature faster. There's always need of speed, because when you grow and you are a bigger company, still you want to grow even more. You need to build new things probably, and you still need to be fast most of times. But there is this strange belief that if you go fast, you do things in a low level of quality, and that's just not true. Okay, the point is that people think that you can be faster with a low quality code, and that's just not true. And this becomes a boomerang very soon. It's not like you do this for 1, 2, or 3 years, the startup now is successful, and then you start having problems with technical debt. You probably already had problems with technical debt like after a month or maybe 6 months, just as soon as you start to have a couple more people in your team working. The problems comes much before we usually think. The fact is, we maybe know the code because we created, or we were here very soon, so we are able to handle them still somehow, but it's not sustainable, and the company needs to start. And of course, when the company needs to start, we need to move fast, very fast. I'm a fan of lean. So I'm totally aware of it, and I'm also fan of this. I believe in this approach, but there are better ways to go fast than producing low quality code. Because if I produce low quality code today, being fast tomorrow, not next year, but tomorrow, will be harder. So I need to find the right balance, and the balance cannot be no quality at all. That's not a balance. Okay? So, as always, it's about choosing the best trade-off. But it needs to be a trade-off. It needs to have a balance. Again, if I go all on speed and zero quality, that's not a balance. That cannot work. Okay? The point, in my opinion, is that most of people think that lower quality gives you speed. Lower quality does not give speed. Lower quality gives acceleration. But the road is never just straightforward. Okay? At some point, you will need to brake. And if you are a startup, you probably need to brake very soon. So your focus shouldn't be on acceleration, right? You need to accelerate. As soon as you have a positive feedback, you accelerate a bit and you still keep it in control. I'm not saying that we don't have to go fast. We need to go fast. I'm not saying we don't need to accelerate, never. Not true. We need to accelerate when we have a positive feedback on what we're doing. So before having the first positive feedback, for example, it's totally useless to go faster. The only reason to go faster is that you need to reduce the cost of your experiment, and that you can achieve it without low quality code. You can achieve it with a good quality of code. An example is that usually, imagine a new application, you need to have, for example, on the website a contact form, maybe, and usually a proper contact form add a person in a mailing list that maybe have some automation to contact him, and then someone will call him through a CRM, etc., etc. So a good trade-off is that the contact form of the first version of your website, just send an email, right? You can do it in 2 ways. One is just write bad code to send an email and still implement with bad code all the implementation of the mailing list, etc. Because then once you need it, you will have it, but you will have it on bad code, because now you don't need that. You want to make a fast experiment, so you need to do it fast, right? That's the problem. You implement something you don't need today. That's a usual problem that causes low quality code to have speed. We don't reduce the scope. We try to do the same thing, but in a bad way. We need to do a simpler thing. Just send an email. You can even do it without any JavaScript. You just need HTML. So just submit a form and send an email. Once you will need something more, you will implement it. You need to strive in general to avoid useless code. If you try, the dry principle is not the only one, right? You don't have to repeat yourself, but you also have to consider Yagni. You are not going to need it. We need to avoid creating things that we are not sure we will need it. And you can say, I'm sure I will need a mailing list with a CRM, etc. Are you? Are you sure that your business will succeed? Are you sure that you will only have 1,000 customers? Or maybe you will have 10,000 because it will succeed even more. You don't know today, because based on how many customers you have, for example, the price of CRMs and mailing services are different. If you have 10,000 customers, maybe you need something more complex. If you have 100 customers, maybe you don't. Maybe with 100 customers, you can afford to start with a product because it costs less. And then in the future, it will cost more, but you will have more customers. And if you build this over time, you can afford it. If you have immediately a lot of customers, maybe you can't. You don't know. You think you know it sometimes, but you don't. So wait for things to happen and wait for problem to rise before solving them. Do not predict problem. Even if you are, I know that this is hard when it comes to some legacy system where there is, where changing things, it's hard. You are tempted to predict things because you know that when it comes, you will not be able to respond fast because changes in the system cost too much. But you can't solve this problem by trying to predict what will come because you will fail. You are predicting the future. It's like estimating. Estimates are always wrong. Why? Because we are predicting the future on something very unpredictable. That's the same. So be ready, but also be aware that you shouldn't produce more code than you need today. So it's better to have a simple email form instead of building bad quality email complex system to achieve simply an email to someone that will call the customer by his phone, right? This is the kind of different thinking that we need to do. We don't have to produce a bad version of what we think we might need. We need to build the simplest solution that can work in our current situation in a good enough code quality. Such feature, for example, if it's an email on HTML, I would probably not even test it because it's HTML. Or maybe I have a simple HTTP request that simulate the email send, because I don't want to test HTML. If I want to test my page, my feature, right? So I can test I can build, for example, a simple automation with Cypress Playwright or whatever that try to send the email from the form, and I can test the API that the form is calling. And that's it. And it can cost me very little because if I do my work in TDD, especially the API part, will cost zero. And I can decide if it's worth it to build the end-to-end test, or I will not because it's just a form. It could even be a no-code form, to be honest. So we need to build things with a reduced scope and not big features, but with low quality because we need something fast. That's the problem. If we really need something big, first of all, we have a problem. We are doing a too big step. Second of all, even if we do it, we need to find the right balance. Let's assume you don't do TDD, because if you do TDD, that's almost for free, because at the same cost, you will have a tested code with decoupling, especially if you do outside in, you will naturally have dependencies through interfaces, easy tests, etc. So, but if you don't, and you have a big things to do, still you should try to split it in smaller pieces of work, and you should try to simplify business needs as much as possible. And you should also, even if the things is still pretty big, try to implement it in a simple way. A simple solution with good enough code is the way. If you still need something complex, you need to find the right balance with the quality. Okay, you can't go to quality zero. For example, you can't afford to build all the tests you want. At least build one big test for the entire feature, the more outside possible. I don't know if it's an API, just test the API, but you need to build some quality. It's a balance. It cannot be zero quality and 100% speed. Otherwise, you will fail and your company will fail, and you need to be aware of this. And you also need to make people aware of this, okay? But that's exactly the best introduction to talk about my point. As I said, there are some practices, and TDD is one of them, that just enable higher quality by default and with zero additional cost. Actually, they reduce cost because they reduce the unplanned work. Since when I started doing TDD, the bugs, issues, and defects of my code has incredibly reduced. Okay, it's almost zero. Okay, when I built a system completely in TDD, it was basically zero. Like one bug in 2 years went to production for the entire team, not only me. So that's huge. You know, a lot of waste thrown away, a lot of waste in investigating bugs in production gone. A lot of time, more time to invest in developing the digital product. We also reduced the cost for the company. Okay? Why? Because we implemented TDD, we implemented continuous integration, continuous deployment, okay? Not continuous delivery, because we wasn't releasing automatically, but it was by tag, but still, it made a difference, you know? And I also want to say that our team didn't have like superstar developers. We were just average developers that was doing things with good practices. And the practices was making the difference more than the technical knowledge. That's one of my strong belief. Practices and methodologies matters more than technicalities. This is more a people kind of work, and we need to work with people and communication much more than we want to admit. This work, software development, is much more about people than about technology than we want to admit. Of course, we need technical skills, but not that much deep as we sometimes used to say in most use cases. And also, that's not enough. You also need people and communication working together. Otherwise, you will fail again, even with the best technical people in the team. So, the point is, we need to handle and manage technical debt. And technical debt is called that way because it's like the financial debt. It's not necessarily bad, okay? I could never buy a house without a debt with the bank, okay? But that debt is sustainable and will be repaid, but will be repaid over time because I can afford it, and so it's useful for my life. I achieved more in my life, and I'm keeping it under control. You know, I kept some safety options so that if I lose the job, I can avoid to pay for some months, etc., etc. So I'm keeping the debt under control. That's the point. It's not like we need to have the perfect design, because first of all, it doesn't exist. There's not such thing as the perfect design for that context or for that situation. It's a trade-off, because if we work with an infinite amount of time on something, I can ensure that even if at some point we say, okay, we're happy, this is the best thing we can do, we have a look at it tomorrow and we still have better ideas. Why? Because there's no such thing as the perfect design. There's always something we can improve or we can do differently. We learn while we develop. So that's also why you shouldn't stick to your code. If you realize, imagine you worked for 4 hours on something, you still haven't finished it, and now you realize that you are a bit stuck. If you delete everything and redo it from scratch with the new knowledge that now you are struggling to implement because you already have the previous code, you will probably be faster. Why? Because reproducing that will not cost you 4 hours, because you learned a lot of things in that moment and in that work. So it will probably take like half of time, and then you will implement the new thing. And maybe if you keep working on the old code, it will take more time to implement a new piece than rewriting. So on a smaller scale, on new code, on your code, sometimes throw away the code and restart is a good option. So we need to consider that tech debt is something that we need to accept. There will always be technical debt in every code base. There's no such thing as the perfect code and the perfect design. There's always a trade-off somewhere. So we need to work with the best technical practices and methodologies that allow us to handle technical debt, manage it, keep it under control, and ensure that our code remains maintainable. The problem is that we as humans change the code. So the code needs to be readable and maintainable. Okay? And it's fundamental that once we develop software, we leave something that it's easy to change. The cost of change needs to be taken under control. And the cost of change is related to technical debt. So that's why technical debt needs to be taken under control. And I don't see technical debt as, it's not like bad code, okay? The real problem with technical debt is it conscious? Is it something we decided to have that way because it's a good trade-off for us? Or is accidental, meaning that we think we did great thing, but in fact we did something not that great? That's the problem. We need to make conscious choices. And the best way to do it is, first of all, study, learn, improve your skills so that you know more things. If you know more things, it's easier to keep things under control. And learn practices and methodologies that can help you getting feedback on your choices. TDD gives you feedback on your design choices. Every minute, every time you do a loop in the cycle of TDD, you get feedback on your design. You immediately realize that the loop is going from a minute for a single loop to 2-3 minutes, and you say, wait, it's taking too much time. You just throw away or take a step back, just a couple minutes of work, and you restart and you keep it clean. That's the kind of feedback that you need to look for. And for example, about feedback on the technical design decisions on software, there's no other thing as TDD. There's no other practice that can give you that kind of feedback every minute. That's also why pair and mob programming especially works better than code reviews. Because code reviews, even if they are not async, which are the worst type of code reviews that you can have, but even if you do it synchronously and you do it together, you still do it after the work is done, or at least the developer thinks that the work is done. And psychologically, that's hard. And also it's hard for the people doing the review to have enough context to give meaningful suggestions. And then you find some reviews where you, for example, consciously decide that a simple solution, it's enough because you have 1 hour, because that thing is urgent. So you find the balance between having a good enough code with a test and going fast. And then someone comes and say, hey, why didn't you do it this way with a very complex design pattern suggested? This discussion doesn't have any sense without the constraint under which I took the decision. Of course, without time constraint, maybe I would have invested more time and find a better solution. Why not? But I didn't have more time. So how can you, not knowing such things, discuss my choices? That's one of the worst things coming from code review. Or at least if we do it synchronously together, I can tell you immediately so we can easily discuss. But when it's async, it's even worse. So TDD, continuous integration, object-oriented programming done well, pair programming, mob programming, ensemble programming. domain-driven design. Why are those kind of practices and methodologies important? Because they help you keeping technical debt under control. That's my vision on practices and methodologies. They are the best way to manage technical debt in a conscious way. That's the point. That's why they work. I have a feedback every minute from TDD, so I keep constantly under control the technical depth of my choices on design because I have a feedback on that. I have a daily feedback on production on how my code is going on production because I do continuous integration and continuous delivery or deployment. So I continuously, daily have a feedback on how hard it is to release something every day. If it becomes a bit harder, it means that I'm not taking care of my technical debt in an efficient way. And I can take care of it now that I have this feedback immediately. I can take some time more, which is a bunch of hours probably. If I never get a feedback, at some point, I realize that it's taking a month to do something that should take a week. And I say, oops, I need to stop for 3 months to do refactoring here. And I mean, if I was a business people and I received this kind of feedback from you, I would say, what? That's just not sustainable for business. That's the whole point for me of agile technical practices and methodologies of achieving, or at least trying to achieve technical excellence, which is, it's an ideal. That's the point. We need to manage technical debt and we need to manage it consciously. And to do it using the best practices and methodologies known in the world is the best way. That's the point. And that's the best way. And that's why the Accelerate book and the State of DevOps report every year show that these kind of practices improve the metrics of teams. Because if you work this way, let's say, you keep technical debt under control. So if my technical debt is under control, I will go faster than the team that doesn't control its technical debt. Okay, I'm done for today. Another Pomodoro is gone. Let me know what you think. How can you do it? You can use YouTube comments, you can use LinkedIn comments in the post where I share the episode, or you can join the Telegram channel of Learn Agile Practices. You find the link in the description because there I share everything I post online, and you can use the comments to share your thoughts with the other member of the community. So it's the best place to share a comment. Now, thanks everyone for listening. See you next week. And until then, happy coding.